Okay, and here's the last one. This is actually a neat problem. The function h is differentiable, and for all values of x, h of x equals h of 2 minus x. Which of the following statements must be true? The integral from 0 to 2 of h of x dx is bigger than 0. H prime of 1 equals 0. And h prime of 0 equals h prime of 2 equals 1. Alright, and this one you left blank.
Yeah.
Alright.
Because this one just was confusing.
Okay. That's alright. This is the last problem on the test. Mm-hmm. Alright, so what do you think here?
Well,
let's go through these.
I'm not too sure why any of them need to be true.
Okay. Well, it's lucky then that there wasn't a choice where none of them have to be true, because maybe you would have answered that. But why don't you sketch a function?
So
that as best you can satisfies this. H of x equals h of 2 minus x.
So
sorry. So we're going to try to h of x equals h of 2 minus x.
So just have a function that is periodic every 2. So maybe we can go like this. Like that.
Okay.
Every 2.
And then it would continue on backwards, so that this would say h of 4 equals h of 2 minus 4, which would be minus 2. So you would have h of 4 is minus 2. It doesn't necessarily have to be periodic like this, but this is a good sketch. All right, let me fold a piece of paper and then test the problem on. So it's a good sketch. So the integral from 0 to 2 has to be bigger than 0. Oops. I knew I'd forget to zoom out eventually. There's your graph. Alright, so the integral from 0 to 2 has to be bigger than 0.
Well, this isn't true because we can flip this over the x-axis.
Okay.
And just have the same shape, but just negative.
Uh-huh.
So this does not have to be true.
Okay. The derivative at 1 is 0.
Well, I've drawn it so it is, but it doesn't need to be. You could shift this hump over, like, so you could have it like that instead.
Okay. So what does this say? Okay, so let's say the hump was at 1.5 instead. So h of 1.5 has to equal
h is 0.5.
Is this true in your graph?
No.
Okay.
So I think the hump actually does have to stay at 1.
Alright, so that's interesting. So if you shift it over, it doesn't satisfy this equation anymore. It loses the symmetry. Okay? The derivative at 0 has to equal the derivative at 2, which equals 1.
Well, here I've drawn it so it doesn't.
Okay.
But so I think it doesn't have to.
Yeah, so this doesn't seem to impose any conditions on the derivative. You could have a function like this and you could just make it flatter at those points.
Yeah.
And so based on your intuition here from your drawing,
I think it's just 2.
2 only. And so let me show you what's going on here. This is a question about the definition of the derivative. And where we want to look is at 1. So f prime of 1 equals the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. Okay. Now this limit comes from, make it more clear that that's an h, both sides, right? Sometimes h is positive, where h is positive and where h is negative. So we're going to break the two cases apart. H is bigger than 0. Okay. So that says I get f of 1 plus h minus f of 1 over h, and the bottom is bigger than 0. And h is less than 0 here. I get f of, well, now it's going to be 1 minus h minus f of 1 over minus h.
Okay.
Yeah, I'm emphasizing it's really f of. I got to be careful because I said h is less than 0, so it's really plus h, but h is negative.
Yeah.
You know what I mean? And then this is negative. But f of 1 minus h, if h is the same size by our this f of h of 1 plus h, if h is positive, plus h of, oh god, I used h twice. H of 2 minus 1 plus h, which is h of 1 minus h. So the top and bottom here are the same.
Okay.
You see that?
Yeah.
So whether it's positive or negative on the top, who knows? But the bottom here is positive and the bottom here is negative. So that means a positive value has to equal a negative value. So what's the only thing that could make that true?
The 0.
Is if the top is 0, essentially. So this has to go to 0. That's the mathematical reason why it has to go to 0. That's a tricky problem. This tricky problem, also a very good problem. The fact that it's differentiable and satisfies this symmetry about x equals 1 forces the derivative to be 0. If you didn't have the fact that it was differentiable, you could have a function that was sort of like a sawtooth like that.
Or you could have one that just kind of goes off, kind of like tangent those.
Well, yeah, it would have to. Then the problem is 1 wouldn't even be in the domain then. But anyway, this is good. You did a good job on this test. The problems that you missed are actually interesting to talk through. Good morning talking through them. Good job.